My name is Rafael Marañón. I am a scholar from Andalusia government in South Spain, attending the SDM program. Before coming to MIT, I was working in IT consulting in Spain. And also, I served in projects for the United Nations in New York and the Spanish consulate in Moscow. As this very exciting day comes to a close, with great speaker having spoken about system thinking, it is a great pleasure for me to introduce you our next honorable speaker, Professor John Sterman. As many of you already know, Dr. Sterman is the J.W. Forrester Professor of Management at the MIT School of Management. And he also the director of the MIT System Dynamics Group. Professor Sterman research focused on improving decision-making in complex systems, including corporate strategy, energy policy, public health, and climate change. Professor Sterman has also pioneered the development of management flight simulator and is the author of the award-winning textbooks Business Dynamics. John Sterman has been also our 7-time best professor by student. I have the privilege to work as a teaching assistant for Professor Sterman's System Dynamics Group at MIT. Ladies and gentlemen, let's welcome Professor John Sterman.
Well, thank you. That was a very generous introduction, and I'm delighted to be here with you. Okay, so I'm going to speak to you this afternoon about systems thinking and climate change, and I thought before I start talking, I should hear from you. So we're going to do a little poll, unscientific poll, multiple choice, you have to vote. So I'm going to ask you, excuse me, about your attitudes about climate change, and let me get some water here. So, how many of you believe that climate change is a pressing, urgent issue posing grave risks to humanity, and we should immediately take actions to mitigate those risks by lowering greenhouse gas emissions? How many of you think we don't really know for sure, it's important, but we can wait and see, and if it turns out that climate change is going to be much more harmful than we currently expect, then we can take action? And how many of you think that it's just not an issue, that either it's not happening or it's not caused by humans, and therefore there's nothing we can do about it, so there's no need for policy action? A few. Okay. And who didn't vote even though I said you had to vote? All right. Well, so this audience is not typical. If you listen to the opinion polls, what you would find is approximately the reversed proportions, that many people in the United States and in most other countries, including other big emitting countries like China and India, Mexico, Indonesia, etc., significant numbers believe that climate change is happening and that it's important, but most of them think we can wait and see. We don't have majorities who are arguing that it's important, urgent, that we do something about it beginning today. And part of what I want to talk about is why that is and what we can do about it. So let me begin with a very quick review of what's happening in the climate arena. So here what we see is global total emissions of carbon dioxide. There are, of course, other important greenhouse gases, methane, nitrous oxide, fluorocarbon family, black carbon, and others. But this is just carbon dioxide from the burning of fossil fuels in billions of tons, gigatons of carbon per year. And what you can see here, since 1990, it's grown substantially and is currently higher than even the worst-case scenario that the IPCC, the Intergovernmental Panel on Climate Change, considers in as inputs to their models to project what the likely future impact of climate change might be. Now, the data I'm showing you up to this point only run through 2008, and we all know the world economy is in a severe recession. Here's the most recent data. Global emissions actually fell, although they remain at or above the worst-case scenario level. Now, what do you think is happening to the concentration of carbon dioxide in the atmosphere? Emissions are going down. Here's another pop quiz for you then. So how many of you think, and you really have to vote, all right? So how many of you think that emissions are going down, so the concentration of carbon dioxide in the atmosphere is still shooting up? How many of you think that it's leveling off in the last year? And how many think that it's going down with the emissions? A couple. All right, great. Well, here it is. This is the concentration of carbon dioxide in the atmosphere. It's at 390 parts per million today, which is about 40% above the pre-industrial level. And if you blow this up, yes, it's still rising. So emissions have been falling, but the concentration is still rising. You're a very highly educated group, and I congratulate you. Most of you got it right. Most people get it wrong, and the question is why. Now, the title of my talk, A Banquet of Consequences, refers to a quote from Robert Louis Stevenson that I like very much when he said, "Soon or late, everyone sits down to a banquet of consequences." And so what is the banquet of consequences that we are laying? What will be on the table that we are setting for our children and our grandchildren if these kinds of patterns continue? If emissions keep growing at or above the worst case business as usual scenario that IPCC considers? Well, here's a chart also from IPCC, and what it shows is temperature change, amount of warming we might have by the year 2100 in centigrade and Fahrenheit, and then various impacts on water availability, food production, on ecosystems, on the weather, etc. Now, there's uncertainty about what these impacts might be, hence you see these arrows that span a considerable range. But one thing we know for sure is that as the planet warms, as the average global surface temperature warms, we're going to see increasing risks of these harmful adverse kinds of events. Now, where are we today? We're here. We're already about 0.8 degrees C, or over a degree, about a degree and a half Fahrenheit, above the pre-industrial level. What is the so-called safe level? Well, there is no safe level of warming, but the scientific consensus is that we really need to keep the total global surface temperature warming increment below 2 degrees C, or 3.6 Fahrenheit, in order to avoid the worst risks. And you can see on this chart exactly how that's going to work. If we're at about 2 degrees, we're going to experience rising sea levels, decreasing agricultural production in many developing regions of the world, decreasing water availability. We're already, even today, experiencing the loss of many glaciers around the world, some sea level Arctic ice decay, and some threats to the large ice caps, etc. But if we go much higher than that, the risks become overwhelmingly likely, including sea level rise that would threaten the major world cities, declines in agricultural productivity around the world, much more intense forest fires, droughts, floods, and heat waves, and the possibility of what is now called, without much understanding, tipping points in the climate, whereby we could pass a point such that no matter what we did after that to mitigate our emissions, climate change might then be in a runaway, irreversible mode. So what are the current projections? The most recent study that I think is really strong and rigorous on this topic comes from MIT, from our climate research program here, and here's the projection. The mean estimate is that under business as usual, we'll have over 5 degrees centigrade, or 9.5 degrees Fahrenheit of warming, expected warming, by the year 2100. And it would keep going up after that. Now, there's uncertainty about that. And so I've also shown the 90% confidence interval. The lower bound is 3.5 C, or 6.3 Fahrenheit. In other words, we might get really lucky. And the climate might be more resilient to forcing with anthropogenic greenhouse gases than we currently expect it to be. And if we get lucky, warming would be 3.5 degrees, 6.3 Fahrenheit, or maybe even a little lower. There's a 5% chance that it would be 3.5 C or lower. On the other hand, we might, with equal probability, be very unlucky, and warming could be as high as 7.4 C by 2100, 13.3 Fahrenheit, with a 5% chance it could be even worse than that. you'll notice that that is off the scale of impacts that the IPCC considered in the fourth assessment report. Now, when I present this in this audience, I think you all understand what a 90% confidence interval means. Certainly my students who are in the audience should do. But when you present this in most boardrooms in businesses and in Washington and in other capitals around the world, policymakers often don't understand what that means. So let me put it in plain language. What this means is that we are playing Russian roulette with the future of the climate, with a weapon in which 19 of 20 chambers are loaded. 5% chance that you won't have a live round in the chamber. There's one difference, though, between that story and classical Russian roulette. We're holding the weapon, our finger is on the trigger, but the barrel's not pointed at our head, it's pointed at the heads of our children and grandchildren. So what we have here is a situation in which the best scientific evidence, overwhelming scientific evidence, is that we have an extraordinary set of risks that require concerted action, and nothing is happening. The Copenhagen conference, which I attended, was basically a failure. In a month or so, the next meeting of the UN Framework Convention on Climate Change will be taking place in Cancun, Mexico. And although there's always an expectation management game, right now the thinking is we will be lucky if we can simply prevent backsliding on the non-binding commitments for inadequate emissions reductions that some nations have made. There's no hope for legislation on this issue in the United States at the moment, or likely after the election. And there's no willingness in China or India or Indonesia or the other major emitters around the world to tackle this problem. So why? Well, the conventional thinking about why it is that we have this enormous risk and people just don't seem to care is that, well, you know, it's uncertainty about the causes and impacts of climate change. And the people who believe that, well, we're still not certain, the solution to that is, well, we need more scientific research. I think that's just absolutely wrong. Now, as an MIT faculty member, I'm completely in favor of more scientific research on the climate. We need to do that, but it isn't going to solve the problem. It isn't going to create greater action. Another theory is that it's just too costly to mitigate, to reduce our emissions. I think that's wrong. I'll talk a little bit later about why. The solution to that is maybe more R&D for alternative energy and energy efficiency investment. And you heard about some of the exciting work that's going on in that arena in the earlier talks today. Another theory is that it's a tragedy of the commons, that, well, we can't cut our emissions in the United States or in Europe if China and India and the other developing nations don't cut theirs. The solution for that is we need to capture the externalities, the negative externalities in the environment via global agreements and creating new markets for carbon through cap and trade programs or other means. I think all of these are important. We need more research on the climate. We need more R&D for alternative energy, and we need some agreements, but we can't get any of that done now. Why do we think that just trying to push legislation through or do more research is going to make any additional difference? I have a different theory. No surprise. My theory is that what's underneath all this is a massive failure of systems thinking, and indeed perhaps just thinking, among all the key stakeholders, including the negotiators and the policymakers, business leaders, the media, educators, and the general public. So the solution that I'm going to offer to you, and I don't believe it's sufficient, I do believe it's necessary, is to create meaningful processes and tools that can help all of these people understand for themselves the systems issues that are at stake, so that the distant and delayed and uncertain consequences that create these risks can become more real to people in such a way that they are motivated to take action. This requires that the tools and processes we use are fast, interactive, completely open box, transparent, absolutely rigorously